Perfect. Well, good morning, everyone, and thank you so much for taking the time out of your schedule to join us for our monthly webinar series. As you all know, today's webinar will be presented by FireMon, and doing the presentation today from their team is Thomas Logley. I hope that's how you say your last name, Tom. Before we get started, I would just like to make a note that you can visit our website to check out upcoming events that we have coming up. And if you're in a noisy environment, if you can please mute your phone or your computer's microphone so as to eliminate background noise for everyone else. If you have any questions during the session, please feel free to type it in the message window, or you can just ask. With that being said, I would now like to turn over the presentation to Tom to begin the webinar.
Hello, everyone. Can you hear me okay?
Yes, I can hear you, Tom.
Excellent, excellent.
Yes, we can.
All right, I'm going to go ahead and share my screen here. And can everyone see the presentation okay?
Yes.
Perfect, perfect. So today's presentation is going to be on optimizing firewall rule sets. My name is Thomas Logley. I'm a senior sales engineer with FireMon. And while we're going to be a little bit FireMon specific in the tools that I show you in how we optimize a firewall rule set, that doesn't mean necessarily that you have to go with FireMon to do this. This is industry standard best practice kind of thing. So we'd love you to go with FireMon, but if not, you should be doing these things whether or not you're with FireMon. So first, a little bit of history. Who is FireMon? Who are we? Why are we all here today? Well, first, it's going to take a little bit of a story. So years and years ago, decades ago, enterprises, as far as technology and security were concerned, were a lot simpler. We had few devices, we had a few people writing the rules, and we had fairly stable static networks. Now, as anybody who's been around for a little while knows, that was not the case for very long. So as we look at the enterprise now, you can see we have countless devices, we have multiple different ways of enforcing the security policy, and we have ever-changing dynamic networks. So just a quick look at some of those technologies out there. We've got Docker, we've got containers, we've got cloud infrastructure going on, we've got virtualization. It's a far cry from the historical setup where we had simple devices with users, firewalls, and forcing access in between. Those days are gone forever, and the picture on the right is the future because it's the present. So in other words, the world has changed, mainly due to the three things you can see right now: cloud computing, virtualization, and IoT, but there's more to that story, and it's only going to get worse, the problem that is. So how do we secure what we call this hybrid enterprise? Well, some of the things that we've taken a look at are automating change management, having compliance reporting and auditing, trying to control cloud. We've got microsegmentation causing trouble. Everything that you see on your screen here is making our job harder. And it's largely these people's fault. Palo Alto, with next generation firewalls, they're leading the charge with these advanced policies. It's not a simple source destination type thing anymore. We've got application intelligence, we've got user intelligence, we have dynamic rules. The world is different from how it used to be. So what we're going to focus on today is how do we optimize these advanced rule sets? And first, why optimize the rule set? What does it get us? Everything has an opportunity cost. So if we're going to spend time, effort, and money to optimize our rule sets, what are we going to get for that? And a few of the benefits that we're going to see here, first and foremost, from a security organization, it's going to increase our security posture. So if you have to be compliant with PCI, for instance, with HIPAA, with NIST, it's a lot easier to maintain and to prove compliance if you have an optimized firewall policy. Beyond that, firewall policies have grown to be so complicated that I would maintain that no single human can hold the entirety of an enterprise firewall policy in his or her head at one time. So that begs to be automated, that begs to have a tool that does that job for us. After that, it makes troubleshooting a lot easier. So when something goes wrong, it's very difficult, since no one person can have that whole policy in their head at that time. An automated tool is really going to help out. You can go back and you can see what changed, you can see why it changed, you can see who made that change, and so on. And then lastly, as far as security is concerned, but sometimes the network people say this should come first, every rule that you have in your firewall that you don't actually need is going to increase the CPU load and increase the processing that your firewall has to do with every single packet that comes in. So we've seen some folks think that they needed a hardware refresh because their firewalls were totally taxed, but after they did some optimization and they moved some rules around, it turns out they actually could put off that hardware refresh for another year, another 2 years, sometimes even another 3 years. So what do I mean when I say optimizing a firewall policy? How do we do that? If you look at the steps right here, we break it down through this process at FireMon. So at the very top, we want to identify what we call redundant and shadowed rules and get those out. And we look to unused rules. These are rules that are in your firewall that haven't seen any traffic. Below that, we use what we call firewall traffic flow analysis. We look at the traffic patterns through your firewall and see how we can optimize that. The next step is to consolidate any remaining rules. So a lot of times folks will have 2 different rules that are virtually identical, except maybe the sources are a little bit different. And then last but not least, by a long shot, is what we call rule set optimization. That has to do with making sure the rules in your firewall are in the optimum order to make sure that firewall doesn't have CPU cycles going to waste. So we're going to dig into each of those a little bit. So redundant and shadowed rules, just some definitions for anyone unfamiliar. A rule in a firewall is called redundant if you can remove that rule and it doesn't change how the firewall passes traffic. A similar but slightly different rule is called a shadowed rule, and that is when you have a more permissive rule or a more broad rule that is above a more specific rule. So because firewall rule bases are evaluated from the top down, what that means is that that overly permissive rule, that broad rule that's up top, up above the more specific rule, is going to catch all of that traffic, and the more specific rule is going to sit in its shadow. So we call those shadowed rules. And how you would identify those with FireMon, this is our platform here, this is Security Manager. We have a report specifically tailored to that. And the way we handle that, we're constantly updating our database with your firewall's configuration. So we have a report here that looks at that configuration regardless of the vendor type that it is, but I'm going to select this Palo Alto firewall. And if we simply run that report, it's going to come back and show us every rule on that Palo Alto that can be removed because it's either redundant or shadowed. So we can see on this report right here, FireMon has identified 5 rules as redundant or shadowed and therefore removable. This top rule here, we recommend removing Rule 16. And if we take a look at Rule 16, we make the recommendation to remove it because it's made redundant by Rule 15 on this Palo Alto firewall. And if we compare the sources here, the destinations, and the application or service, we see that these 2 rules are in fact identical. So you obviously will never get any traffic matching Rule 16 because Rule 15 is going to catch it all, and you can safely delete Rule 16 without altering that traffic pattern through your firewall whatsoever. If I scroll down a little bit lower here, I can show you an example of a shadowed rule. See right here, we recommend removing Rule 25 because we've identified that it is shadowed. And if we look, sure enough, Rule 25 is shadowed by Rule 24. And Rule 24 is not a particularly good firewall rule. It's an any with an action of accept. But nonetheless, Rule 25 is going to be shadowed by Rule 24. So in this case, we're going to spot that for you and flag it. And now you might want to remove Rule 25, but you might instead, depending on why these rules are in place, want to reorder them and perhaps put Rule 25 above Rule 24. So that's shadowed and redundant rules. After you get rid of those, the next step is to find any remaining rules that are still unused over a period of time. A lot of folks like to run these reports for a year because they figure if a rule has not seen any traffic for an entire year, it's probably safe to remove it. One added note, it says down there that sometimes a rule is only used once a year, and I will add an additional note of caution. If a rule is designated as a disaster recovery rule, that rule might not see any traffic for more than a year period. So you may not want to delete or remove any rules that are DR rules. And going back to the FireMon platform here, we've got another report. Again, this has to do with usage. So after you add a firewall to FireMon, we're constantly monitoring them for usage. And I'm going to pick on that same Palo Alto here. Change that number of days, an entire year. So now if we dig into this report, it's going to show us, ordered by the number of hit counts, every single rule that saw traffic on that firewall, as well as these 11 rules that didn't see any traffic. So these 11 are a great place to start because we know for the previous year, these rules did not get any usage whatsoever. So that's access that was present in your firewall that you didn't really need to have there because nobody used it. Again, this is the general process you want to go through when you're tightening up your firewall. You want to find any rule that doesn't have any usage and get rid of that. And beyond that, you want to find any object within a rule that doesn't have any usage and get rid of that as well. So what do I mean by that? If we look at this top rule right here, you can see the hit count has 62 million hits over the previous year. But if you look at where those hits were within the rule, if we look over at the service column here, we can see that virtually every single one of those hits was on this service HTTP object. And then this other object called service HTTPS had 0 hits for an entire year. So while the rule as a whole has a good number of hits and shouldn't be scrapped just based off of that, if you dig deeper into the rule base itself, into this individual rule, you can see this service object should likely be removed because it had 0 hits. There was 0 traffic using this service object for an entire year. So does anyone have any questions on anything they've seen so far? Sounds like no. So I'm going to go ahead and move on. So here, again, as an example, this is what the rule base would look like within Palo Alto. And again, without seeing the usage, if you have usage turned off, you're really blind as far as which rules need to go where. We really recommend that you always have usage on because then you can see these hit counts and you could get rid of rules if they have 0 hit count. So that's what you can do with the rule if there's no usage on it. But what do you do if you have what we call an overly permissive rule? Well, in that case, we recommend doing a traffic flow analysis. And what we mean by that is you want to identify the source and the destination of any overly permissive rules in your existing firewall policy and understand how that traffic is flowing through in order to tighten up that rule. So to see that in action, let me switch back to the platform here. So with traffic flow analysis, it's kind of like a packet capture or a TCP dump for an individual rule on a firewall. You want to take a look at every single traffic pattern, traffic flow using that overly permissive rule. So in the case of this report I'm about to show here, this was indeed an any rule on this Palo Alto that was turning it from a very expensive firewall into a very expensive and very useless router because it was letting every single packet through once it got to this rule. So if we scroll down here, we can see over that 1-week period during which this traffic flow analysis was done, FireMon identified 152 different individual flows that used that overly permissive rule. So we can see there's a mix, there's some IPv6 here, we have some IPv4, and we're going to sort all of those by hit count. And the idea here is that when you spot those overly permissive rules and you do this traffic flow analysis, you can go line by line and identify, is that a valid source? Is that a valid destination? And are these valid services? Do we want this traffic to go through our enterprise? If the answer is yes, you would put in a rule that matches what we've displayed here and allows this traffic. If the answer is no, so say for instance this source IP going to that destination IP on these services here is not something that you want, in that case you would want to put in a rule above your overly permissive rule that blocks this traffic. And at the end of that exercise, as you've gone down line by line and you've identified every single traffic flow as either legitimate or not legitimate, illegitimate, at the end of that exercise you can safely delete that overly permissive rule, which in this case, again, that's an any rule. That's terrible for a firewall. At the end of this exercise, you delete that rule and you've tightened up your security policy quite a bit. Does anyone have any questions on traffic flow analysis and how you might use that? All right, I'll continue. So the next step that we do after you've gone through all of that, after you've gone through and found the removable rules that can't ever see any traffic, you've gone through and sorted your rules by rule usage, and you've gotten rid of your overly permissive rules with traffic flow analysis, and you've gotten rid of your objects that didn't see any usage, only after that process should you start to consolidate rules. Because only after that process do you know your remaining rules and your remaining objects inside your rules are all good, quote unquote good. So there's one remaining step we can do to make them even better, and that is to consolidate them. So what we mean by that, it's to collapse rules that can be safely consolidated without changing the behavior of the firewall policy. So to see what that would look like in our tool, back over here. And again, we have a rule consolidation report. And since, again, this is coming from our database, it makes everything quite simple. Just select the firewall, run the report. Then a second or two, you've got the results here. And on this Palo Alto, we've identified there are 3 rules that are candidates for consolidation. So we can see the first recommendation right here. We recommend you consolidate Rule 17 into Rule 7. We'll show you what the consolidated rule would look like here. This green plus item there shows what would be added to the existing rule. And then beyond that, just to make it easily palatable for human eyes, we're going to show you what the existing Rule 17 looks like and highlight what is to be consolidated into Rule 7. So these are virtually identical in their current state, Rule 7 and Rule 17, other than the services. Rule 7 has syslog, whereas Rule 17 has all the same source and destination, but instead of syslog in the application, it has TFTP. So it's almost the same rule. It's putting a lot of overhead on your firewall to have to evaluate traffic against 2 rules instead of 1. So we would recommend moving TFTP into Rule 7. If I go down a little bit lower here, this recommendation is to consolidate Rule 12 into Rule 11. And this one's a little bit more complicated. We've got a couple different destinations to add here. So we have the same source object, these Linux machines. We have the same destination zone, any and untrust. And if you look at the destination objects, we've got quad 8/32 there. And then we have these 2 web servers right here. So again, it would make sense to consolidate this, since your firewall, instead of having to evaluate 2 rules, only has to evaluate 1 after you've consolidated them. And then last, on this particular firewall, we would recommend consolidating Rule 17 into Rule 7. You can see, again, it's just TFTP going up into syslog right there. So any questions on rule consolidation, why you should do that, why that's a good idea for your firewall? I'll take silence as no. So after you've done that, after you've gotten rid of the redundant rules and the shadowed rules have been moved around, and you've gotten rid of objects that don't have any usage, and you've modified your traffic flow to get rid of overly permissive rules, and you've consolidated any rules that you can, the last step here is rule set optimization. So what we mean by that is you can look at the usage of all the rules on your firewall, and then you can reorder them to make sure that the rules that are getting the most usage appear toward the top of your firewall rule base. Because if you have a rule that's near the bottom of the rule base and your firewall has to evaluate every single rule above it first, well, if that rule is seeing the bulk of your traffic, that's a lot of unneeded, unnecessary overhead that's getting placed on your firewall. So you could do that manually. There's obviously no problem with that. If you have a tool like FireMon, we have a report just for that. If you do highly used rules low in the rule base, again, I'm going to pick on that Palo Alto firewall. And let's look at usage previous 10,000 days. Quickly run that report. And here you go. So these rules are receiving 5% of the traffic through this firewall or greater, and they are in the bottom half of the firewall policy. And those numbers, I can tweak those to get whatever results I'd like. But the idea here is that this rule is in the bottom half of the rule base, and it's receiving 85 million hits. So your firewall, for each one of those hits, had to go through half of the rule base or more in order to get to this evaluation point where the traffic would actually match the firewall and be permitted through. So if we move this rule higher up in the rule base, that will allow us to send more traffic through that firewall. It'll reduce the overhead on that firewall, and it may very well, as we sometimes see, put off the need for hardware refresh to increase the power of your firewalls. You can see there are 3 rules identified here, so this next one is actually even worse. It's lower down in the policy. It's Rule 23 versus Rule 13, and it received 144 million hits versus 85 million. So again, this is a candidate for moving up in your rule base, but you can see you would only want to do this after you've cleaned up your rules a little bit, because this rule is actually an any rule, any source, any user, only a couple destinations here, but any application and any service. So the firewall cleanup process really has to be done in order, because you don't want to move a rule like this up near the top of your rule base in this case, because it's overly permissive. So you have to clean it up first before you do that optimization. So again, the general steps, if you want to optimize your rule base, you want to identify any redundant and shadowed rules. You want to remove any redundant rules. You want to reorder your shadowed rules so that they're no longer shadowed. After that, you want to look at your rule usage and find any time that a rule has not seen any traffic for a given time period. And that would make sense differently for different organizations. So maybe it's 6 months for some, maybe it's a year for others, maybe it's 2 years for other organizations. And after you've done that and deleted those unused rules and pruned out those unused objects within the rules, the next step would be to employ a traffic flow analysis type tool in order to identify any overly permissive rules and then to tighten those up with more specific rules that take place of that overly permissive rule. After you've cleaned all your rules up, you want to try to consolidate any remaining rules together. That way you have the fewest rules in your rule base as possible. And then after all of that process is finished, you want to go through rule set optimization and look at reordering your rule base so that the rules that get the most traffic are the rules that are the highest up in your rule base. That way you're making your firewall run as efficiently as possible. And using FireMon, it's virtually the same process. We just have reports and custom tools that make it a little bit faster, a little bit easier, a little bit more straightforward than if you were going to try to do it manually. There's some other things that I didn't cover here today. So these are items that you should be doing. They're irrespective of policy optimization. These are things like rule recertification. So virtually every standards and compliance body on the planet is going to require that rules periodically go through recertification, where you take a look at the rule and you identify whether you actually still need this rule or not. You have someone certify that it is access that's still required. After that, you want to do risk analysis. So just because somebody says they need a rule and it looks like it's a good rule, you still want to do risk analysis on that to see what that rule opens access up to and see if there are any vulnerabilities associated with that the rule is enabling. Beyond that, you want to make sure that you're doing good change detection and reporting. So if someone makes a change at 2 in the morning and it's not approved, you want to be notified of that immediately, and you'd like to know who made the change, what changed, why they changed it, and then hopefully if they have a backup plan or an approved plan. After that, if you've got compliance you have to adhere to, it would be nice to have a tool that would automatically enforce that compliance. So whenever someone puts in a rule that breaks your PCI compliance, for instance, you would like to have a tool or some automated way of alerting you that, hey, this rule is breaking your PCI compliance and you better fix it before the auditors show up. After that, it would be nice to have proactive validation. So what we mean by that is when you're putting in new rules, you want to validate that they're not going to break things like PCI compliance before the rule ever lands on your firewall. So we can do some of that. Beyond that, device hardening standards. So you would always want to look at industry standard practices, things like not allowing telnet from the internet to your internal zone. You'd want to look at best practices such as that and have those always in mind when making changes and reviewing any changes on your firewall. So again, some of the benefits from an optimized firewall policy: it's going to increase the overall security posture of your organization. It's going to make compliance a lot easier. It's going to decrease the probability and the susceptibility of human error, making problems for everybody anytime you change a configuration. It's going to make firewall troubleshooting much easier. It's going to accelerate restoration times, those times to get back up and running after someone's made a mistake. And then last but not least, it's going to reduce the CPU load and the processing load, and it may well extend the life of the firewall platform. So does anyone have any questions for me or anything that they've seen here today? All right, sounds like no. Once again, I'd like to thank you all for being here. My name, again, is Thomas Loggle. I'm a senior sales engineer with FireMon. And if you have some information that you'd like me to know, if you have any questions that you think of after this is over, my email address is thomas.loggle@firemon.com.
Thomas, thank you so much for your time, and thank you everybody for joining the session.
Thank you.
You're welcome.